Good evening everyone, good evening. I welcome you all again to JEE Enthuse. I hope you guys are doing great, having a good time. Well people, you can let me know in the chat box if I'm audible and visible to everyone, right? Just let me know in the chat box if I'm audible and visible to everyone. Just give me some green signal from the chat box so that I'll get to know whether I'm audible and visible to everyone or not. Hello Manisha, hello James, hello Kalaivani, hello Shrikant, hello Aishwarya, hi Shivani, hi Phoenix, hi Chinmay, welcome. Hello Shrikant, hello Shruti, welcome everyone, welcome. Perfect. Hi Rakesh, hello Neat Aspirant, hi Sohaib. Surely James. Okay. Yes, Tushar, basically, I couldn't take the session in the morning on NEET Lead channel. So, tomorrow on NEET Lead, it's going to be the mock test for the NEET students, and day after tomorrow, it's going to be your atomic structure. Yeah? All right. Hi, Gaurav. Hello, Annaline. Nice name you have. So, people, as you all must be knowing, tonight we are going to do the second mock test for the JEE 2021. Yeah? Okay. So before starting the session, the ones who do not know me, let me introduce myself. My name is Wassim Bhatt and I'm your chemistry master teacher right here on this JEE Enthuse channel. Yeah? Okay, the ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well, right? And at the same time, do not forget to hit the bell icon so that you get the notification of every single session which we will be taking live on this JEE Enthuse channel. Yeah? Okay. So people, you can let me know in the chat box if you guys are super duper excited about the complete chemistry mock test number 2. Yes? Give me some thumbs ups in the chat box so that I'll get to see the Josh of the session, yeah? Right? Let me see the Josh of the session first, then only we can start the session directly. Without wasting a lot of time. Yes, give me some thumbs up in the chat box. Perfect, guys. Wonderful. Wonderful. So let's get going. Let's get started with the second mock test for the JEE 2021, right? And welcome again to the Rank Booster JEE 2021 series. Perfect, guys. So let's get going. Let's get started with the first question, which is on your screen. The question was asked in Mains 2020, 5th September. Have a look on the first question. A very simple and the basic question. The correct order of the ionic radii of O di negative, N tri negative, F negative, Mg di positive, Na positive, Al tri positive is. The question from the periodic classification, or you can say from atomic structure, right? Yes, and the question was asked in Mains 2020, 5th September attempt, right? Give it a try. Let me know the answer in the chat box. Give it a try and let me know the answer in the chat box. Fast. Give it a try fast. Well, a lot of people are saying option A, yeah? What about the rest of the people? What about the rest of the people? Suresh, I'm basically a civil engineer. Yeah. Okay. Perfect, guys. Perfect. So majority of you guys are right. Let's see how this sort of equation is solved. First of all, as you all can see right here, all the species which are given to me, right? All the species which are given to me, your O di negative, N tri negative, F negative, Mg di positive, Na positive, and Al tri positive. All these species are basically isoelectronic ones, right? These are the isoelectronic species. What do we mean by the term isoelectronic species? These are the ones which contain same number of electrons. So in all these species, you'll be having same number of electrons present, right? In O di negative, there will be 10 electrons, N tri negative 10 electrons, F negative 10 electrons, Mg di positive 10 electrons, Na positive 10 electrons, and Al tri positive 10 electrons at the same time, yeah? So all these are isoelectronic species and all these have got same number of electrons, right? But the number of protons are not same in all, right? Since oxygen has got the atomic number of 8, so it has got 8 protons. Nitrogen, it has got 7 protons, its atomic number is 7. Fluorine, its atomic number is 9, so it has got 9 protons. Mg, its atomic number is 12, so it has got 12 protons. Na positive, sodium, its atomic number is 11, so it has got 11 protons. Aluminium, it has got 13 protons, right? So right here I can say more the protons, more the number of protons, yeah, more the number of protons means simply more will be the effective nuclear charge, and more the effective nuclear charge, less is going to be the size. Less is going to be the size, right? So people, on the basis of the number of protons present in all these species, we can clearly give the order of the ionic radii, okay? Since the maximum number of protons are present in aluminium, 13 protons, so its effective nuclear charge will be maximum and its size will be minimum, right? Okay, so aluminium has got the minimum size, followed by your Mg di positive, right? Followed by Na positive, right? Then comes your what? Then comes your N tri-negative, sorry. Then comes your F negative, then O di negative, then N tri-negative, right? So the correct order is going to be the first one, yeah? Right? As simple as that, as simple as that. Very, very simple and ordinary equation this is, correct? Since the number of electrons are same everywhere, it is just you'll be deciding on the base of protons. More the protons means more the positive charge, more the positive charge, you can say more the effective nuclear charge, and more is the effective nuclear charge, less is going to be the size. As simple as that, right? Okay, so first one is going to show the correct order among all, yeah? Okay, wonderful. Let's move on to one more question. This is one more question on your screen. The question was asked in your mains 2020, 7th Jan, yeah? Okay, give it a try. Let me know its answer. A very simple question. Oxidation number of potassium in K2O, K2O2 and KO2 respectively will be. The first one is the normal oxide, second one is the peroxide, and the third one is the superoxide, yeah? This question is enough to confuse you, yeah? This question is enough to confuse you, correct? It is not going to be option B, it's going to be option A, yeah? It's going to be option A, guys. Look here, look here. See, we have got K2O, which is the normal oxide of potassium. Then we have got K2O2, which is the peroxide of potassium. Then we have got KO2, which is the superoxide of potassium, right? Okay. Over here, oxygen is going to show normal -2 oxygen state. In the peroxides, oxygen shows -1 oxygen state. And in the superoxides, oxygen shows -1/2 oxygen state. But we are not supposed to check the oxidation state of oxygen. We are supposed to check the oxidation state of potassium. Potassium, it belongs to group 1, right? Potassium belongs to group 1, right? If the potassium belongs to group 1, we already know group 1 elements, they always show +1 oxidation states, right? Because they have got only one electron in their outermost shell. They lose that electron, correct? So potassium over here will show +1 oxygen state. In this one also it will show +1. In this one it will show +1. Since potassium, it belongs to group first elements, right? And group first elements, they'll be always showing the +1 oxygen state, no matter what, yeah? Okay. So option 1 again is going to be the correct one among all. I'm sure it's again clear to you, yeah? Give me some green signal from the chat box so that I'll move on to the next one. Give me some green signal from the chat box so that I'll get to know whether it's clear to you or not. Let me know fast, let me know fast, let me know fast. Perfect, guys. Let's move on to one more question then, yeah? Let's move on to one more question. The question was asked in JEE Mains 2021, 16th January attempt, okay? JEE Mains 2021, that means this year, 16th Jan, it was asked, right? See, guys, what the question says. A 6.50 molar solution. So we are given with the solution whose molality, is given to us as 6.5. Okay. This solution, it contains KOH as the solute. We are given with aqueous KOH solution. Aqueous KOH solution means the solute which I'm using is KOH and the solvent which I'm using is simply water, because I'm using aqueous over here. Has the density of 1.89 grams per centimeter cube. So the density of solution is also given to us. It's given to us simply as 1.89 grams per centimeter cube, or you can write grams per ml. The molarity of the solution is, and we are given with the molar mass of KOH, that means molar mass of solute, we are given with M2 value. It's given to us as 56 grams per mole. What we are supposed to calculate? We are supposed to calculate, I guess, the molarity, yeah? I guess we are supposed to calculate molarity of the solution. People, it's very simple. You're given with molality and you're supposed to calculate molarity, right? There's a one direct result which I gave you in the basic concepts in the mole concept, if you remember. Okay, no need to use any sort of brain, just remember that basic formula. Molality is always equal to 1000 multiplied by molarity of the solution divided by 1000 multiplied by density of solution minus molarity multiplied by molar mass of solute. This is the simplest relation by means of which you can calculate molarity of the solution. Now we will understand. Since molality is given to us, M value is given to us as 6.5, yeah? This is something which we are supposed to calculate, right? This is something which we are supposed to calculate. Density of solution is also given to us, right? Molality is given to us. Density of solution is given to us, 1.89. Molar mass of solute is also given to us as 56. You just need to cross multiple. You'll be getting the value of molarity from this here as 9. So molarity of the solution will be simple 9 over here, right? Okay? Yeah? So option 3 is going to be the one which is correct. Absolutely, guys. You all are right. It's going to be option C. Yeah? Simple. From now onwards, you just remember this relation. Whenever you need to convert molality into molarity or molarity into molality, just follow this simple equation. Yeah? Okay? I'm sure it's clear to everyone. Hello, Shashidhar. Welcome to the channel. Welcome, welcome. Perfect, guys. Let's move on to one more question then. Okay. In the following molecule, hybridization of carbon A, B, C respectively are. Okay. The question was asked in your JEE Mains 2021 18th March attempt. I mean, this year only it was asked, right? Give it a try. Let me know its answer. A very, very simple and basic question this was. Yeah? Simple and basic question it was. Simple, you'll be doing what? You'll be calculating the number of sigma bonds. That's it. You'll be calculating the number of sigma bonds. See guys, if I talk about this carbon has got 3 hydrogens attached like this and 1 sigma bond with this carbon. So there are total 4 sigma bonds. 4 sigma bonds means Sp3 hybridization, right? What about this carbon? So this is 1 sigma, this is the second sigma, this is the third sigma. So it's going to be simply Sp2 hybridized carbon, right? And the carbon number C, again you can calculate the number of sigma bonds, 1, 2 and 3. So it's again going to be Sp2. So the order of hybridization of carbon number A, B and C is going to be what? It's going to be first one is carbon A is Sp3, then carbon B is Sp2, carbon C is also Sp2. So option A again is going to be the correct one among all, yeah? Just let me know in the chat box if it's clear to everyone. Just let me know in the chat box with some thumbs ups so that I'll get to know whether you got it or not, yeah? No, Sam, I do not know Telugu, bro. Hello, Amir, what's up? Perfect. Yes, Harsha, you can go ahead with your doubt. Perfect, guys. Let's move on to one more question then, right? Okay, the question was asked in your JEE Mains 2021 26th Feb attempt. That means this year only it was asked, right? See what the question says. A certain gas obeys PV minus B is equal to RT, right? A certain gas, I've got a certain gas, it follows the equation P multiplied by Vm minus B is equal to RT. Some gas is following this equation. The value of dz by dP at constant temperature is x times B by RT. So it's given in the equation that dz divided by dP at constant temperature is given to us as what? Is given to us as x times B divided by RT, right? What we are supposed to calculate? We are supposed to calculate the value of x. It's a very, very simple question. See guys, how this question is to be solved. First of all, this Vm stands for the molar volume. Vm stands for the molar volume. Let me tell you first of all this. Vm stands for the molar volume, right? What does that mean? That means I've taken 1 mole of the gas. That means I've taken 1 mole of the gas, right? That means I'm talking about 1 mole of the gas, correct? So I'll be simply now writing it as P multiplied by V minus times P multiplied by B is equal to what? Is equal to RT, right? People, since we need to calculate the value of dz upon dP, what is z? Z is the compressibility factor, yes? So I'll be dividing this equation throughout divided by RT. I'm dividing this equation throughout divided by RT. So what I'll be getting right here, PV divided by RT. If you remember, the value of compressibility factor is Z. It's basically equal to PV divided by nRT. Since I've taken the number of moles of gas as 1, so Z is simply equal to PV divided by RT. Yeah? Okay, so instead of this PV by RT, I'll be writing Z. Z will be equal. This is 1, right? And this term will go on that side. It's going to be 1 plus PV divided by RT. correct? This is the value of Z which I got. This is the value of compressibility factor which I got. Now, understand. Now, what am I supposed to calculate? I'm going to differentiate this Z with respect to pressure. I'm going to differentiate with this Z with respect to pressure, correct? So, I'll simply say dZ upon what? dZ upon dP at constant temperature will be equal. Differentiation of constant is 0. If I'll differentiate this term with respect to pressure, it will simply become B divided by RT, right? Now, people, if you compare these two equations, let's call this as equation number 1. Let's call this as equation number 2. Correct? This is basically dZ divided by dP at constant temperature. It's equal to B divided by RT. If you compare these two equations, what is the value of X? X is basically in front of B by RT. In front of B by RT, we have got nothing. That means we have got 1. So the value of X is simply equal to 1. On comparing these two equations, you clearly get the value of X as 1 from here, right? I'm sure it's clear to everyone. Yeah? So option 1 is going to be the correct one among all. You can let me know in the chat box if everything is damn clear till here so that I can move on to the next one. I'm sure you got to know how to solve this sort of equation, yeah? Right? Surely, Mohan, why not? Just give me some thumbs ups in the chat box so that I'll get to know whether you got it or not, yeah? Simple, right? I got the expression for Z. I differentiated this Z with respect to pressure, right? I got something like this. Over here, I got to know the value of X is 1. As simple as that, yeah? Perfecto. Let's move on to one more question then, yeah? This is one more question. What is the geometry of SF4, including lone pairs of electrons, if any? Okay. JEE Mains 2020, 2nd September. Last year, JEE Mains, the question has been asked. Give it a try. It's a very simple question, and I'm sure you guys are going to kill it, yeah? It's a very, very simple question. It's a very, very, very simple question, guys, yeah? If you just remember the steric number method, you can clearly tell the answer of this question. It's a very simpler one. Perfecto. Let's move on. Let's see how this question is to be solved. We are given with the molecule SF4, first of all, yeah? We are given with the molecule SF4, sulfur, right? And there are some 4 fluorines. I'm making the rough diagram over here, right? This is some rough diagram which I'm making. For example, like this, okay? Sulfur is forming 4 bonds with fluorine, 4 sigma bonds with fluorine, right? First of all, sulfur has 6 valence electrons, if you remember. So out of 6 valence electrons, it has used 1, 2, 3, and 4. Out of 6 valence electrons of sulfur, it has used 4 valence electrons to form the bonds. So there'll be 2 electrons still left on sulfur, right? I'm calling this as the lone pair. So how many sigma bonds this sulfur is forming? It is forming 4 sigma bonds. How many lone pairs this sulfur has? Sulfur has got 1 lone pair, right? If you remember, steric number is defined as sigma bonds plus lone pairs. Sigma bond is 4, lone pair is 1, 4 plus 1 comes out to be 5. If the steric number comes out to be 5, the hybridization is going to be Sp3D. And in case of Sp3D hybridization, what is the geometry? Geometry is something which we call as trigonal bipyramidal, right? Geometry will be trigonal bipyramidal, correct? If I ask you what, see, this is the geometry, this is not the shape, this is the geometry. If he asks about the shape of the molecule, remember, whenever we'll be having 4 sigma bonds and 1 lone pair, the shape is going to be seesaw type, right? It's going to be a seesaw shape. Shape is going to be seesaw and geometry will be trigonal bipyramidal, right? Let me know in the chat box if it's clear to everyone so that I can move on to the next one, yeah? Yes, Priyanshi, exactly. Dhruv, day after tomorrow, bro. Day after tomorrow, we'll be doing the structure of atom, 3rd session on NEET Lead channel, right? Just give me some thumbs ups in the chat box so that I can move on to the next one. Shankar, if you want to join my batch, there's a link in the description box of the video. You need to click on the link. You need to use my coupon code. You'll be automatically getting enrolled into my batch, yeah? Perfecto. Let's move on to one more question then, yeah? Let's move on to one more question. A certain orbital has n value equal to 4 and the azimuthal contour number ml equal to -3. Yeah, the number of radial nodes in the orbital will be. The question was asked in your mains 2012. Long back it was asked, right? Just give it a try. Let me know its answer fast. Let me know its answer fast. It's a very simple and the ordinary question, yeah? People, just remember the formula. Just remember the formula. Total nodes in the orbital is equal to n minus 1. Out of these total nodes, there will be some spherical, or you can call them as radial nodes, and at the same time, there will be some angular nodes as well, right? How to calculate the angular nodes? Angular nodes is given by the value of L, and spherical nodes it's given by the formula n minus L minus 1, right? Since we are supposed to calculate the radial nodes over here in this case, yeah, what is the value of n that's given to me? N value is given to me as 4, right? What is the value of azimuthal quantum number? Either you represent azimuthal quantum number by ml or you simply represent it by L. L value is given to us as minus 3. Just put the value of n as 4, put the value of L as minus 3, right? Okay, just a second. It cannot be minus 3. It's plus 3, sorry. It's plus 3, right? It's plus 3, it's not minus 3. Okay? Yeah? It's plus 3. Because azimuthal quantum number L is always equal to 0 to n minus 1, right? So 0 to 4 minus 1, that means 0 to 3. Either the value of L is going to be 0, or it's going to be 1, or it's going to be 2, or it's going to be 3, right? So he has used the value of M as plus 3 over here, correct? So it's going to be plus 3, right? Minus 1, the value over here comes out to be 0. So 0 will be the radial nodes in this case over here. So option D is the one which is going to be correct among all. Right? Let me know in the chat box fast. Let me know in the chat box fast. Correct? Okay, let's move on to one more question then, yeah? Perfect. The question is again asked in your mains 2012, right? The question is again asked in your mains 2012. Yes, Mukesh, you can go ahead with the doubt. Yeah? An organic compound undergoes first order decomposition, right? An organic compound undergoes first order decomposition. The time taken for its decomposition to 1/8 and 1/10 of its initial concentration are T1/8 and T1/10 respectively. What is the value of T1/8 divided by T1/10 multiplied by 10, right? Okay. This is the question. Can you let me know its answer fast? Can you let me know? Can you let me? Yes, Shrujana, I'll be doing that. I've already started that chapter on Neatly channel. Priyanshu, that will be done day after tomorrow, okay? Let's see, guys, how this question is to be solved. Understand. Let's assume I have got a first order reaction as A gives B. Let's assume it's a first order reaction. Correct? Let's assume its rate constant is K. Yeah? At time t is equal to 0, the initial concentration of reactant is A0. The initial concentration of product is 0. Correct? Now, what's going to happen? When the reaction will start, the concentration of reactant will keep on decreasing, and a stage will reach when the concentration of reactant will be equal to 1/8 of A0, right? Okay. And the time taken by the reactant to decrease its concentration from A0 to A0 by 8, that is denoted by T1/8, right? Similarly, when the reaction further goes on, the concentration of the reactant keeps on decreasing, and there will be a time when the concentration of reactant left will be 1/10 of A0, correct? And the time taken for the concentration of reactant to decrease from A0 to A0 by 10, that is denoted by T1/10, correct? So this is the concentration of this is the concentration of reactant left at time t is equal to T1/8, right? And the concentration of reactant left I represent by 80. This is the concentration of reactant left at time t is equal to T1/10. So this is the value of 80, correct? So I got two conditions. I got two conditions right here. When the value of t is equal to T1/8, at that time the concentration of reactant left is A0/8. When the t is equal to T1/10, at that time the concentration of reactant left is A0 divided by 10. Yeah? Okay. Now people, since it's the first order reaction, so I'll be using what? I'll be using the integrated rate equation for the first order. I'll be using the integrated rate equation for the first order. First of all, I'll be writing something like this. T1/8 is equal to 2.303 divided by K log of A0 divided by AT. A0 divided by AT. At time T1/8, what is the value of AT? AT is A0 divided by 8. A0 divided by 8. That 8 goes up, and I can write that 8 as 2 raised power 3, simply, yeah? 2 raised power 3. Or you can write log of m to the power n is n log m. So 3 will come to the front. It's going to be 3 log 2. So it's going to be 3 log of 2, correct? And log 2 value is also given to me as 0.3. So 3 multiplied by 0.3, correct? This is the value of t1 by 8, correct? Now people, what I'll be doing, I'll be writing t1/10th as well. t1/10th, as per your integrate rate equation, it's going to be 2.303 divided by k. It's going to be log of a naught divided by 80, right? At time t1/10th, it's going to be a naught divided by 80. What is the value of 80? 80 is simply a naught by 10, right? A naught divided by 10, that 10 comes up like, right? Log 10 is simply going to be equal to 1. So t1 by 10 is simply going to be equal to 2.303 divided by k, yeah? What is something which I'm supposed to calculate? I'm supposed to calculate t1 by 8 divided by t1 by 10. That means I'll be simply dividing these two equations, right? I'll get something like this. T1 by 8 divided by t1 by 10 is equal to 2.303k, 2.303k cancel. So 3 multiplied by 0.3 comes out to be 0.9. But people, I'm supposed to calculate the value of t1 by 8 divided by t1 by 10 multiplied by 10. So multiply this side by 10 as well as this side by 10. So the value of this term I was supposed to calculate, which came out to be 0.9 multiplied by 10, that means 9. So the correct option is going to be option B over here, right? Let me know in the chat box if it's clear to everyone. Let me know in the chat box if it's clear to everyone fast, yeah? Perfect, guys. Wonderful. Just give me some thumbs ups in the chat box. That's great, Mohammed Amin. That's great. Yes, Wajid, exactly. He's the best. Just let me know in the chat box if it's clear to everyone. Yeah? Perfecto. Let's move on. Let's move on to one more question. Okay, a very simple question. The order of stability of the following carbocations. The question was asked in your mains 2013. Yeah? The question was asked in mains 2013. Just give it a try and let me know fast. Let me know fast. What do you think about this question? Shashidhar, you can go for the mole concept. Let me know fast. What do you think? Thank you, thank you, thank you, everyone. Perfecto. Yes, Arun, you can do that. All right. A lot of people are saying option 1. A lot of people are saying option C, option D. So let's check it out what the option is. See, guys. Over here, you have got the positive charge on this carbon. Right here, you have got positive charge on this carbon. And right here, you have got positive charge on this carbon, right? Okay. You need to see which one is the most stable, right? Yes. Now we will understand. Now we will understand. This is your pi bond. This is sigma. This is the positive charge, right? Okay. So this pi sigma positive charge, I mean vacant orbital over here, this is in conjugation. I mean you have got the conjugation right here. Pi sigma vacant orbital with the positive charge conjugation, right? Over here you do not have any sort of conjugation. No conjugation at all. Yeah. Over here you can see this is pi, this is sigma, this is vacant orbital with the positive charge. Again, you have got the conjugation in this case, which is again your pi sigma vacant orbital conjugation, right? Okay. Now we will understand. Now we will understand. Due to conjugation, can I say over here in this case, resonance will be possible? Yes, absolutely. The first molecule can show resonance. This one cannot show resonance. This one can show resonance at the same time, right? Okay. As we know, resonance increases the stability of the carbocation right here. Okay. So first and third, definitely they are going to be more stable than the second. So second is the least stable among all. Second is the least stable among all, right? So let's not talk about second. Now among first and third, which one is more stable? Now you need to check where in conjugation is more. Where will be the number of resonating structures more? Resonating structures are more in the third case. So third one is more stable than that of first one, right? So first comes in the middle and third comes in the front. So third one is going to be maximum stable, followed by the first one, followed by the second one, yeah? Let me know in the chat box if it's clear to everyone. I don't know from where these spammers come. Vedantu JEE Enthuse English. Can you please block this guy, this Firdaus Pathan? Yeah? Perfect. Just give me some thumbs ups in the chat box. Give me some thumbs ups in the chat box if it's clear to everyone. Fast. I'm doing great, Tuhin. I'm doing great. Thank you. Chinmay, chemical kinetic session will be done day after tomorrow. Yeah. Perfecto, guys. Let's move on. Let's move on to one more question then. Let me see if you can solve this one or not. Yeah. Okay. The question was asked in IEEE 1999. My God. Give it a try and let me know its answer fast. Give it a try and let me know its answer fast. Give it a try. Fast, fast, fast. Yeah. Give it a try, give it a try, give it a try, and let me know its answer fast. It's a very simpler one, yeah? It's a very simpler one from the chapter solid state, right? Perfecto. Wonderful, guys. Have a look, have a look. Have a look how to solve this sort of equation. As you all must have heard, density of the unit cell is always equal to Z multiplied by M divided by Na multiplied by A cube. This is the simplest formula to calculate the density of the unit cell, right? As simple as that. Now people, can I say something like this? Can I say density of the unit cell is directly proportional to the effective number of particle, or we call this Z as the rank of the unit cell as well, divided by A cube? I can say something like this as well, right? Now see, look at the equation. A metal crystallizes into two cubic phases, FCC and BCC. We have got the metal M. It is making two unit cells, right? Firstly, it's making FCC. And in the second instant, it's making BCC, body-centered cubic unit cell, right? Whose cell lengths are 3.5 and 3 angstroms. So when this metal is making FCC, at that time, edge length A is equal to 3.5 angstroms. Yeah? And when this metal makes BCC, at that time, edge length A is equal to 3.0 angstroms, correct? I need to calculate what? Calculate the ratio of the density of FCC to that of BCC, correct? So people, see, first of all, the value of Z for FCC, as you all must be knowing, that's 4. And the value of Z for BCC, as you all must be knowing, that's 2. Yeah? Okay. Right? Now we will understand. Can I say something like this? Density of FCC divided by density of BCC will be simply equal to Z of FCC divided by Z of BCC multiplied by A of BCC divided by A of FCC raised power 3, right? As simple as that, right? Yes. Right, as simple as that. So people, Z value for FCC we know, correct, that's 4. Z value for BCC we know, that's 2. Edge length for BCC, it's given to us as 3. Even this value, edge length for FCC is also given to us as 3.5. You can solve it out, right? You'll be getting the value exactly equal to 1.26 over here, yeah? Just let me know again if it's clear to everyone. So the correct option is going to be 1.26, yeah? Okay. Perfecto. Perfecto, guys. Wonderful. All right. Let's move on to one more question then. Arrange the following amines in the decreasing order of basicity, right? We are given with some 3 amines and we are going to arrange them on the basis of the decreasing order of their basicities, okay? Give it a try and let me know its answer fast. Give it a try and let me know its answer fast. Give it a try. It's a very, very simple question, guys. Well, people are saying it should be option D. Is that? Well, some are saying option 2 is the correct one. What about the rest? Okay, so let's get to see what the correct option should be. Basically, we are supposed to arrange them on the basis of their increasing basicity, right? Sorry, decreasing basicity. So we are supposed to check which one is the maximum basic among the all, right? See guys, first of all, this nitrogen, it'll be having a lone pair over here. Similarly, this nitrogen has got the lone pair. Yeah, even this nitrogen has got the lone pair, correct? Okay, right? First of all, that nitrogen which will be having more tendency to donate the lone pair will be more basic. That nitrogen which will be having more tendency to donate the lone pair will be more basic, right? Okay, now understand. Right here, what is the hybridization of this nitrogen over here? You can clearly say hybridization of nitrogen is going to be, it's 2 sigma bonds, 1 lone pair, so 2 plus 1, 3, it's sp2. right? What about the hybridization of this nitrogen over here? You should not say 3 sigma bonds and 1 lone pair, that means steric number 4, sp3. No, see, this lone pair, it is in conjugation with this pi bond and this pi bond. That lone pair which remains in conjugation, we do not have to consider that lone pair for the hybridization. So hybridization of this nitrogen again is going to be sp2. 3 sigma bonds, right? Okay. Now, what about this one? Since this lone pair is not in conjugation with any pi bond or something, so its hybridization is going to be sp3, correct? First of all, in case of sp3 hybridization, what is the percent S character of this nitrogen over here? Percent S character is going to be 25%, okay? Percent S character is going to be 25%. Percent S character over here, in this case, is going to be 33. In this case, it's again going to be 33%, right? People, you all must be knowing electronegativity is directly proportional to the S character. More the S character means more the electronegativity, right? Which one is having less S character among the following? This one, last one is having less S character. Less S character means less electronegativity. Less electronegativity means more tendency of this nitrogen to donate this lone pair. So third one is going to be maximum basic, right? Because its lone pair will be easily available for the donation, right? So third one is the maximum basic, correct? Now among first and the second one, which one is more basic? See guys, this lone pair, it is involved in the conjugation. This lone pair is involved in the conjugation. This lone pair is not involved in any sort of conjugation, right? So the availability of this lone pair is more than the availability of this lone pair. So wherever lone pair is going to be available, there only basicity is going to be more. So first one is going to be more basic than the second one. So 3, 1, 2 is going to be the order. Is there any option like that? 3, 1, 2? Yes, 3, 1, 2 is going to be the order, right? Let me know in the chat box if it's clear to everyone. Yeah, let me know in the chat box. That's great, Amin. Thank you, Ishan. Thank you. Perfecto. Wonderful, guys. Let's move on to one more question then. Let's see if you can solve this one or not. Just a second. Okay. This is the question. The question was asked in your JEE Mains 2020 25th Feb attempt, right? Again, a very simple question from the what? From the thermodynamics, yeah? Perfecto. Let's see how this question is to be solved. Understand, guys, we are given with a reaction over here, yeah? What are we supposed to calculate? We are supposed to calculate what? What we are supposed to calculate? Delta U is given, the value of delta H at temperature 298 Kelvin for the reaction, okay? Assuming R is this one and this one, okay. First of all, we are given with a reaction. The first thing which I would like to calculate for the reaction is delta Ng, which is going to be number of moles of gaseous products minus number of moles of gaseous reactants, yeah? So first of all, how many gaseous products do we have? We have got 1 plus 1, 2. So 2 moles of gaseous products minus. How many moles of gaseous reactants? 3 by 2 moles of gaseous reactants. So 2 minus 3 by 2 simply comes out to be 1 by 2. So delta Ng for this reaction is simply 1 by 2 over here, right? Okay. Right? Delta Ng for the reaction is 1 by 2. Okay. Now we will understand. We know the formula delta H is equal to delta U plus delta NGRT. This is the relation between delta H and delta U. I hope you remember this, correct? What are we supposed to calculate? We are supposed to calculate the value of delta H, right? Since we are supposed to calculate the value of delta H, that too in kilojoules, right? It will be equal to delta U. What is the value of delta U in kilojoules? It is simply minus 742.24 kilojoules, correct? Plus delta Ng value, as we have calculated, as 1 by 2. Our value is going to be 8.314 joules per Kelvin per mole multiplied by temperature is simply 298 Kelvin, right? But people, let me tell you, the units of this whole term right now is going to be in joules because I have taken the value of R as 8.314 joules per Kelvin per mole. So the units of this whole term right now are going to be in joules. I'm going to divide it by 1000, then only it can come in kilojoules, right? Now it's your job to do the calculations and get the value of delta H from here, right? Okay. Right. Let me know fast if it is clear to you. Yes? Okay, when you solve the calculation, you do the calculation part, you'll be getting the value exactly as minus 71.0 kilojoules per mole, right? This is the value of delta H which we were supposed to calculate. As simple as that, right? Perfecty. Perfect, perfect, guys. Wonderful. So let's move on to one more question then. We have got one more question, and the question is from the chapter Equilibrium, and the question was asked in your JEE Mains 2026 September, right? 6th September, the question was asked. The value of Kc is 64 at 800 Kelvin for this reaction. The value of Kc for this reaction will be. A very, very simple question. Understand how this question is to be solved. See guys, the first reaction which is given to me, that is N2 gas plus 3 times H2 gas. It is in equilibrium with 2 times NH3 gas. Correct? This is the reaction which is given to me. Its Kc value, it's given to me as 64. Correct? It's given to me as 64. Okay. Now people, I'm supposed to calculate the Kc value for this reaction. So first of all, I'll try to make this reaction from the given reaction. Okay, this reaction is given to me whose Kc is given, right? Now, I'm going to make this reaction from this reaction. So what I'll be doing? First of all, let me reverse the given reaction. When I reverse the given reaction, it becomes 2 times NH3 in equilibrium with N2 gas plus 3 times H2 gas. And when we reverse the reaction, what happens? Equilibrium constant is inversed. If the equilibrium constant of this reaction was 64, the equilibrium constant of this reaction is going to be 1 by 64, right? Yes. Now people, what I'll be doing, I'll be simply multiplying this reaction by 1 by 2. If I multiply this reaction by 1 by 2, it's going to be NH3 in equilibrium with half of N2 gas, right? Plus what? Plus 3 divided by 2 times your H2 gas, correct? So since I have multiplied this reaction by 1 by 2, so that 1 by 2 goes to the power of equilibrium constant. So it's going to be 1 divided by 64 raised power 1 by 2. The value comes out to be 1 by 8. So 1 by 8 is going to be the equilibrium constant of this reaction, which I was supposed to calculate, right? So 1 by 8, is there any option? Yes, option number 1. Just let me know in the chat box if it is clear to everyone so that I can move on to the next one, right? Give me some thumbs ups in the chat box so that I'll get to know whether you got it or not. Yeah? Give me some thumbs ups in the chat box, people, fast, right? Perfect. Wonderful. Wonderful, guys, great. Let's move on to one more question then, yeah? Let's move on to one more question. Okay, the question was asked in JEE Mains 2021, 16th March, right? Okay. The question was asked in Mains 2021, 16th of March. Can you let me know what should be the answer of this question? Just give it a try. Just give it a try. It's a very simpler one. Just give it a try. Well, people are saying it should be option C. Is that? Should I be believing you? Well, we will see how this question is to be solved. Understand. We are given with two salts. One is your A2X and one more is your MX, yeah? A2X and MX, right? These are the salts which are given to me. First of all, A2X and MX, they have got same value of solubility product. Their Ksp value is same. So Ksp value for this salt as well as this salt is 4 into 10 raised power minus 12. This is something which we are given with, right? Now people understand. First of all, this A2X would have got dissociated as 2 times A positive, right? Plus X di negative. Similarly, this MX, it would have got dissociated as M positive plus X negative, right? Let's assume the solubility of this salt is S1. So the concentration of A positive is going to be 2S1 and the concentration of X di negative is going to be S1, right? Let's assume the solubility of this salt is S2. So concentration of M positive is going to be S2. The concentration of X negative is going to be S2 as well. If I will write the Ksp expression for the first salt over here, it's going to be concentration of A positive raised power the stoichiometric coefficient 2 multiplied by concentration of X di negative raised power its stoichiometric coefficient, right? So Ksp will be equal to concentration of A positive is 2S1. So 2S1 ka square means 4S1 square. 4S1 square multiplied by S1 means 4s1 ka cube. So from here, you'll be getting the value of s1 cube is equal to Ksp divided by 4. So what is the value of Ksp which I'm given with? I'm given with something as 4 into 10 raised power what? 10 raised power minus 12 divided by 4. 4 and 4 got cancelled. So s1 will be equal to 10 raised power minus 4 molar over here, right? Because this was s1 ka cube, right? Is equal to 10 raised power minus 3 minus 12. So this 3 will go to the right hand side, it will become cube root. So s1 value will come out to be 10 raised power minus 4. As simple as that, right? Okay. Now people, since we got the s1, now it's time to calculate s2, right? So Ksp for the second salt is simply going to be equal to what? It's going to be s2 multiplied by s2, which is s2 ka square, right? So s2 is going to be equal to under root of Ksp. What is the Ksp which I'm given with? Ksp is given to us as 4 into 10 raised power minus 12, right? So S2 value will be simply 2 multiplied by 10 raised power minus 6 molar. Well, you got to know the value of S1, you got to know the value of S2. I'm supposed to calculate the ratio of solubility of A to X to the solubility of Mx, right? So basically, I'm supposed to calculate the value of S1 to the S2. Well, S1 value you got to know as 10 raised power minus 4. S2 value you got to know as 2 into 10 raised power minus 6, right? That 10 raised power minus 6 will be going up, so it becomes 100 divided by 2. 100 divided by 2 simply means 50. So 50 is going to be the answer of the equation, yeah? Can you let me know in the chat box if it's clear to everyone, right? Give me some thumbs ups in the chat box if you got it. Absolutely, it's going to be 50. Perfecto, guys. Wonderful. Let's move on to one more question then, yeah? Let's move on to one more question. Okay, in the following compound, the favorable site for the protonation is, A, B, C or D, okay? The favorable site for the protonation is the site A favorable for protonation or B or C or E or D? What does it exactly mean? See guys, basically you are going to check the availability of lone pair, okay? Wherever lone pair is going to be maximum available, that site is going to be the most favorable for the protonation, right? Okay? Right. Remember from now onwards, wherever lone pair is going to be maximum available, right? There only that site is going to be favorable for the protonation, right? Now you need to check which lone pair is available right here. Yes, you need to check which nitrogen can donate a pair of, which nitrogen can donate this lone pair easily. That nitrogen which can donate the lone pair easily, I can say that nitrogen is the most favorable site for the nitration. Yes, now we will understand properly. First of all, this is the lone pair. We have got the lone pair, this is sigma bond, this is pi bond. So this lone pair is in conjugation. It's in conjugation right here. Yeah, it's in conjugation. So if I want to calculate the hybridization of this nitrogen, I do not have to count this lone pair, right? So it's making 2 bonds with hydrogen, 1 bond with carbon. So 2 plus 1, 3. So sp2 hybridized, okay? Now similarly, if I talk about this nitrogen, is this lone pair right now in conjugation? It's not in conjugation, right? So I need to count this lone pair for hybridization. So 1 sigma, 2 sigma and 1 lone pair. So again, it's going to be sp2 hybridized nitrogen. Similarly, this is also going to be sp2 hybridized. Similarly, this is also going to be sp2 hybridized, correct? This is also going to be sp2 hybridized. Now I need to check wherein the lone pair is the most available, right? Wherever the lone pair is going to be most available, there only protonation is going to be favorable, right? See, this lone pair is in conjugation with this pi bond, right? This lone pair is not in conjugation, right? This is in conjugation. I'm using a different color to show it to you. Let me tell you, this lone pair is in conjugation, right? What about this lone pair? This is a lone pair, this is sigma, this is pi, this is also in conjugation. Yeah, this is not in conjugation. So people, these two lone pairs, they are in conjugation with the pi bonds. If they are in conjugation, they'll participate in the resonance. And if these two lone pairs, which I'm denoting by these red circles, if they'll participate in the resonance, there will be less availability of this lone pair and this lone pair for the protonation, right? So most available sites for protonation are going to be C, B and D, right? C, B and D, C, B and D. These are the favorable sites for the protonation. A and E, these are not the favorable sites for protonation because these lone pairs are basically participating in the resonance, due to which the availability of the lone pair for the protonation decreases. As simple as that, yeah? Right? Let me know in the chat box if it's clear to everyone. Okay? Perfect, guys. Let's move on to one more question then. Let's move on to one more question. The coordination number in this case, okay, give it a try and let me know the answer fast. Give it a try and let me know the answer fast. Murli, you should solve mock test now. Okay, give it a try and let me know fast. It's a very, very simple question, guys. See, first of all, I need to check the coordination number, right? Yes. Now, first of all, this is a ligand oxalate, right? This is H2O. This C2O4 dinegative, this ligand is bidentate, if you remember. And this water, it is monodentate. It is monodentate ligand, right? See, since this oxalate is bidentate, so one oxalate ion, it forms two coordinate bonds. Since we have got 4 oxalate ions, so 4 oxalate ions are going to make 8 coordinate bonds, right? Similarly, H2 is monodentate. One H2O molecule forms one coordinate bond at a time. So 2 H2O molecules will form 2 coordinate bonds. So total, how many coordinate bonds are being formed? Total, there are 10 coordinate bonds being formed. So the coordination number over here in this case is going to be 10. As simple as that, right? Perfecto, guys. Majority of you people are right. So wonderful. So let's move on to one more question then, yeah? This is one more question. Which of the following molecules is least resonance stabilized? JEE Mains 2017. Which of the following molecule is least resonance stabilized? What do you think about this one? Which one is least resonance stabilized? Basically, you are supposed to check which one is least stable. Which one is least stable among the all? See, guys, first of all, see, all these structures, these are the cyclic structures, right? All these structures are cyclic. Okay, even this is sp2 hybridized carbon, sp2, 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 right? So it's a planar structure. There is 2 electrons, 2 electrons, 2 electrons. So total 6 pi electrons involved in the complete cyclic conjugation. Over here, we have got 2, 4 and 6. Again, 6 pi electrons involved in complete cyclic conjugation, right? In this case, again 2, 4, 6. 6 pi electrons in the complete cyclic conjugation. Right here, is there a complete cyclic conjugation? No. This is sp2, this is sp2, this is sp2, but this is sp3. This is sp3. So this molecule is not planar overall, right? Okay. So people, since 6 pi electrons means aromatic, right? As per Huckel's rule, 6 pi means aromatic. 6 pi means aromatic. This one, it is not planar at all. So this molecule is going to be non-aromatic. Well, let me tell you, the stability of non-aromatic is less than that of aromatic. So which one is going to be least stable? That is going to be your fourth one, right? No, Chinmay, I cannot do that. Rakesh, fourth one is not anti-aromatic. It is non-aromatic. Okay, it's non-aromatic. Perfect. Wonderful. Let's move on to one more then, yeah? Okay, in the following skew conformation of ethane, right? Dihedral angle is. Okay, dihedral angle is. Basically, you're supposed to check the angle between this hydrogen H dash and this H double dash, right? Check the angle, check the dihedral angle between this H dash and H double dash. Okay, what do you think? What do you think? What do you think? I'm talking about this H dash and this H double dash, right? You need to check the dihedral angle. Yes? Give it a try fast. Well, we will check. If I'll ask you, what is the angle between this bond and this bond? What do you think? What is the angle? What is the angle? Fast. Give it a try. What do you think about the answer of this question? I'm asking you. Well, people are saying 151, some people are saying 180. What about the rest of the people? What about the rest of the people? Guys, it's going to be 149, right? It's going to be 149, correct? It's going to be 149. See, first of all, if you look at this bond angle, from here, if you look at this dihedral bond angle, I'm asking, okay? I'm telling. This one and this one, the angle is simply 120 degree, right? This angle, this bond and this bond, the dihedral angle is 120, right? And this part is given in the equation, it's 29. So it's simply going to be 120 degree plus 29. It simply comes out to be 149. So 149 degree is going to be the answer of this question. As simple as that, right? Okay. Okay. It's a very simple question, provided you know how to make the Newman's projections, right? It's a very, very simple one. Perfect. We have got one more question. The question was asked in your mains 2019, right? Mains 2019, the question was asked, right? Give it a try and let me know the answer. You're supposed to write the answer in the form of a raised power something. Okay, let's give it a try. Well, first of all, if you remember your Nernst equation, what is your actual form of Nernst equation? E cell is equal to E naught cell minus what? Minus RT divided by NF. It's going to be ln of QC. This is the actual form of your Nernst equation, if you remember. Yeah. If the standard electrode potential for this cell is 2 volts at 300 Kelvin, okay, E naught cell value is given to me. E naught cell value is given to me as 2 volts, right? At 300 Kelvin, the equilibrium constant for the reaction at 300 Kelvin. Okay, so basically the cell is at equilibrium, right? When the cell is at equilibrium, at that time E cell value is taken as 0, right? So I got to know something as E naught cell. Since the cell is at equilibrium, so E naught cell will be equal to what? It will be equal to RT divided by NF. It is going to be ln of, instead of QC, I'll be writing KC, KEQ, equilibrium constant, right? Because the reaction is at equilibrium, correct? So people, it's simply going to be equal to E naught cell multiplied by NF divided by RT is equal to what? It's equal to ln of equilibrium constant to the base E, right? So you can convert this logarithmic form into the exponential form. You can clearly say equilibrium constant KEQ is equal to E raised power, is equal to E raised power. E raised power what? E raised power E naught cell. E raised power E naught cell multiplied by NF divided by what? Divided by RT. Correct? A very, very simple form you got, right? So it's going to be E raised power. What is E naught cell value? E naught cell value is given to me as 2 volts multiplied. What is the value of N? See, zinc is undergoing oxidation from zinc to Zn di positive. That means it's losing 2 moles of electrons, and Cu di positive, it is gaining 2 moles of electrons. So right here in this net cell reaction, how many moles of electrons are being exchanged? 2 moles of electrons are being exchanged, right? 2 moles of electrons are being provided by zinc, and same 2 moles of electrons are being accepted by Cu di positives. So you can say N value is 2. What is the value of F? Faraday's constant, that's 96500 coulombs, right? Divided by R. R value simply you'll be taking as 8.314 multiplied by temperature is given to me as 300 Kelvin. You need to solve it. You'll be getting something as E raised power something, right? You'll be getting answer as E raised power something, correct? And the correct answer is going to be E raised power 160, right? This is something which we have done over. E raised power 2 multiplied by 2 multiplied by 96500 divided by 8 multiplied by 300. It's approximately coming out to be E raised power 160. Yeah? Okay? As simple as that. Correct? Wonderful. Let's move on to one more then. Okay, this is one more question. The increasing order of the reactivity of the following halides for the SN1 reaction will be. What do you think about this? What do you think about this? Give it a try. Let me know the answer first. Give it a try. Let me know the answer first. See guys, we need to check the reactivity towards SN1. It depends on the stability of the cation which gets formed, right? Your SN1 reaction, it gets completed in several steps. One is the ionization step, then is the nucleophile attack, right? Yes, if you remember. So basically, your rate towards SN1, it depends upon the stability of the carbocation which gets generated in the ionization step. So first of all, when there will be ionization of the first molecule in water, this Cl will leave as Cl negative, so there will be positive charge on this carbon. Similarly, this Cl will leave as Cl negative, positive charge on this carbon. This Cl leaves as Cl negative, positive charge on this carbon, right? Now you need to check basically the stability of these carbocations. Okay, So which carbocation is the maximum stable? This carbocation is maximum stable because it's resonance stabilized. You have got a benzene phenyl kind of a ring over here attached, yeah? Okay, right? This carbocation, it's resonance stabilized, right? So its stability is going to be maximum. So if the stability of the third carbocation, if the stability of carbocation getting generated in the third molecule is maximum, that means the rate of this molecule towards SN1 will be maximum, right? So third is going to show maximum rate. Now check the stability of these two carbocations. See, how many alpha hydrogen this carbocation has? It has got 3 plus 2, 5 alpha hydrogens, right? How many alpha hydrogens this carbocation has? It has got only 2 alpha hydrogens. So the first carbocation is stabilized by 5 alpha hydrogens through hyperconjugation. So first carbocation generate is more stable than that of second. And whatever is going to be the stability order of the carbocation, same is going to be the rate of SN1 reactions over here, yeah? So it's going to be 3, 1, 2. 3, 1, I mean the third one is going to show the maximum rate towards SN1. Third one is going to show maximum rate towards SN1, then your first, and at the end, your second. So option 2 is the one which is the correct among all, yeah? Again, a very, very simpler one, yeah? Okay? Right? Wonderful. So it's going to be option 2. It's going to be option 2 which is going to be the correct among all. I'm sure it's clear to everyone. So people, we have got one more question. The question was, oh my God, somewhere asked in IIEEE 1990, okay? And this is something which I'm giving you as the homework. Do let me know the answer of this question in the comment box, yeah? That's great, Vishruta, that's great. You have done 14 questions right out of 19 till now. That's wonderful. That's actually wonderful. Congratulations. So people, do let me know the answer of this question in the comment box. Yeah, this I'm giving you simply as the homework. So with this, I end the today's session. But before ending the today's sessions, okay, let me tell you one important thing. The ones who have not joined into the JEE 2021 crash course yet, people, this is the best and the last option for you guys to score higher in your mains examination, right? And what all things we are going to cover here in this JEE 2021 crash course? Well, people, we are going to cover your whole syllabus before your upcoming JEE 2021 examination in 120 sessions on the actual Vedantu platform. Apart from that, no need to worry about the test series, no need to worry about the mock tests, everything is included over here. There will be some special sessions with the experts which will train you how to solve the questions in lesser time, and everything will be there in detail, right? From start till your JEE Mains level. Everything will be done. But this is the crash course for the ones who are going to write the JEE in 2021. That means upcoming exam, right? And people, how to get enrolled in this crash course batch? There is a link in the description box of the video. You need to click on the link. You need to use the coupon code as WSCC, which is Wassim Sir's crash course, right? On using this coupon code, you'll be getting some 40% off, and after the 40% off, you are just getting this crash course for 6K. Do get enrolled in this as soon as possible, because this is the best and the last option for you guys to shoot up your performance, yeah? And at the end, there is a link in the description box of the video as well for the Telegram. Do click on the link, get added to the Telegram group, and stay updated about the classes, right? And the ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel as well. It was nice meeting you. I'll see you guys tomorrow at the same time. Till then, you take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye. Bye. God bless you all. Yes, Priyanka, absolutely.